these properties, the definition of the definite integral of f on the interval a to b specifies that a is less than b. That's how it has to work. If it's the other way around, then we're going to have to make it negative, if you remember from our previous example. Now, however, it is convenient to extend the definition to a equals b is greater than b. All right, so we kind of already talked about this, right? So those examples kind of give you an intuitive idea of what these look like here. Now, if f is defined x equals a, all right, that it has a value, right? Then if you get a, that's right, its area has to be 0 because the width is essentially 0. So therefore, if you saw a to 3, pi to pi, whatever, it's going to be 0. Okay, it's just a sliver. If f is integrable, I'm going to have to Google Translate integrable. Integrable. I never use that word. If you can integrate f on a to b, then if I'm going from a to b and then all of a sudden I went from b to a, well then that is reversal, right? And then we already talked about that. All right, so just split now. But here's the thing with this now, that this is telling you this doesn't make any sense. So switch it and just put a negative sign. Okay, just remember that it is essentially negative. So that's, we can play algebraic tricks now and draw geometric shape. Now I do believe for the rest of the section drawing geometric shapes, but in the next section we do not want to draw e plus 5x. We don't want to draw that and then add up areas. We're going to do that. We want to be more sophisticated. The editor talked about it. If I'm going from say B to A, I don't know why they chose. Wait a second. This is a typo. Yep, absolute typo. Switch that. Okay, if you're going from A to B, what you can do, find that going from A to B is hard for some reason, and which is going to happen. Then what you want to do is you want to go up to a place where you can calculate the area really conveniently, stop and call it C area, and then go from C to the rest of the actual interval, and then add that area. So sometimes you have two kind of strange spots. You can calculate one area, calculate the other, and then add them. So that is absolutely a typo, or else we'd have to make this negative. Okay, so properties of definite integrals. Now this is interesting because what it says is let's say that I have some function that has a multiple, like 2, 3, constant, right? What it means is I can actually take that out of here on fx. Let's everything is multiplied by 1,000,000 here. Like, why carry the 1,000,000 along with the function when you can take the 1,000,000, put it on the outside, get this integral here, and then multiply by 1,000,000. Okay, so it's like a little shortcut. We can kind of just make your number smaller, or just, whatever factors can be. Less numbers is better math. For number 5, this one is interesting because what it's saying, what if I had some constant and the k would look like this? Let's just say it's 5, right? And I'm going from, wait a minute. Where are they going from? Why are they switching? This isn't. Okay, A to B. This is another typo. Looks like she copied and pasted this whole thing. These are B's. Oh my gosh, what a terrible situation. Okay, that is email worthy. That is email worthy, Gene. Okay, so we are going from A to B. You go from A, the interval right here is A to B. Okay, A is less than B. The only time you have a problem is when they switch it here. You switch back and make it. Don't she? I think she honestly copied and then copied it right there. Each one. That's so. What's going to happen here? To be okay. This is just arbitrary number 5. All right. Symbol. Now, what it says here is if I have a constant here, I have this really formula there. Now, what this symbol really is the area of the rectangle itself. If I did have if it was what I have from here, there's a function that goes from here, right? It's 5, so it's just in. I want the area of here to here. All right, it's obviously a rectangle. And what is that rectangle? Well, the height is actually, or k, right? It could be 10, 12, whatever. Okay, this width is actually the distance from B to A. And so if I took the 5 times B minus A, it's actually the area under the curve, or in this case, right? This represents the height times the width. So try not to be, don't let this be confusing for you, because you're going to have to kind of remember that if you're doing a constant, you can actually just do 5 times B minus A. Okay, so put that on a shelf. Now here is saying two functions, if you had one adding to the other, and that was going from A to B, same thing, A to B of x, go A to B with the g of x, and just add them together. So they're kind of integration conveniently works like this because you're basically adding, subtracting areas, right? So example, okay, looks like I'm going to be 3 videos. So let's say that A to B, A to 4. Okay. All right. We're going to treat these as non-typos. All right. But here, these are. So I have g of x. I have the interval. Okay. So I'm going to start and just read this. The integral from b to a of g of x dx. I can like that. And say the integral from b to a of g of x with respect. Well, I know that going from a to b of g of x 3. So because the limits of integration are actually switched, that sign because of that. I'm going now in the wrong direction. Was yes, okay. Now here I'm switching it. So I'm making it the area kind of above the x-axis, right? So now with this one, now it looks like I have a constant here, so I can actually take that count and actually go from a of just with of x, and so from a of dx is actually just 8. So it's like what I have is 2 times 8, which is 16. All right. So, basically got these little areas already calculated, and you're just playing with the symbol here. Okay. Now here we're going A to B of 5 dx. Oh, so it shows that it looks like it is actually here. That's totally. What I want to do then is look at this as 5 minus, I'm sorry, times B minus A. I don't know what B minus A is. I don't know what B is. I don't know what A is. So I stop. That's it. That is actually fine. Here. I already did this one here. I've got 2 functions here. One's constant, one's g of x. This is A to B a to b of g of x with respect to x. So that would actually equal 5 times b minus a, which I already figured out in C. Now, what this one is actually negative, so it looks like it's -3. All right. What do I? Nothing. There's no a. There's no b like that. Really legitimate AP question right there. Okay, you can have already got those integrated here. I have those actual. So I'm going to split this up. So practice splitting this up using the right? If I'm going to split this up, that d of x basically needs to be this to both, right? So that this has to happen correct. All right. And when I'm looking at 8 minus 5.5. Okay, that's it. 1102, right? Okay, so now this is getting here. All right. So a goes to 4. And 4. Oh man, this is actually so much easier. My thing is that a went to 4, a went to 4, and then 4 went to b. What is that really? Okay, what it really is a to b, right? Because you just made up 4 for no apparent reason, and so you have essentially this actually equals that is 5/2. So and pit stop at 4, but now just kind of realize the first arrow right goes from a to 4. This and then to take place, right? You go from here to here, and that's the next function, okay? And then it kind of is immediately added forward. All right, we'll stop there.